Hi everyone, welcome to my channel. In this video, I would be going to discuss about basic proportionality theorem. Get started. The theorem statement is if a line drawn parallel to one side of a triangle to intersect the other two sides in distinct point, the other two sides are divided in the same ratio. The statement involves these three principles. A line parallel to one side, triangle have three sides, among three sides any one side parallel to another one line, intersect other two sides in distinct point, then other two sides divided in the same ratio. These three principles involved in this theorem. So meaning of this theorem is meaning of the statement a line parallel to one side of a triangle. This is the meaning. Here triangle ABC, three sides AB, BC and AC. BC is the side, D is parallel to side BC. This is the first concept. Intersect other two sides in distinct point. Here FG is the line, D is also line. These two lines have differences there. FG passes through only one point A. So the theorem says the line drawn parallel to one side intersect other two sides in distinct point. Here D is intersect AB and AC, but FG is intersect only one point A only. So theorem must says intersect other two sides in distinct point. FG is the line parallel to BC, but which passes through only one point A. But D is parallel to BC, DE intersect other two sides in distinct point, but FG is passes through the same point. FG passes through the same point, DE passes through distinct point. D is intersect other two sides BC, but FG is not intersect other two sides BC. So FG parallel to BC, in this case, basic proportionality theorem not applicable. If FG parallel to BC, in this case, basic proportionality theorem is not applicable. DE parallel to BC only applicable in basic proportionality theorem. The first one, the line drawn parallel to one side of a triangle, the line intersect other two sides distinct points. So DE intersect AB and AC in distinct point. So in this case only basic proportionality theorem is applicable. FG is the line parallel to BC which is not intersect other two sides. BPT is not applicable in this case. FG passes through same point A. DE parallel to BC which intersect other two sides in distinct points. So this case first parallel to one side and intersect other two sides and distinct point. Then only basic proportionality theorem is applicable. So some additional note is must note to understanding the theorem. So first one, triangle of same base with the same parallels are equal area. Here two triangle ABC and ABD. The area of ABC and ABD are equal. Here AB parallel to CD. AB and CD are parallel lines. AB is the same base of triangle ABC and ABD. So here parallel line included two triangles, the areas are equal because the distance between the parallel lines are equal. Distance means height of the parallel lines are equal. So area of ABC is equal to half into AB into height. Area of ABD also is equal to half into ABD into height. Height of both triangles are equal, base same. So area of triangle ABC is equal to area of triangle ABD. So triangle same base with the same parallels are equal area. Here AB is the same base of triangle ABC and ABD. So these two triangles areas are equal. Then triangle in same baseline and same vertex is equal height. Here triangle ABC, many triangle is there, triangle ABD, triangle ADE, triangle AEC, ADC, ABE and ABC minor triangle is there. So base of all the triangles is same line. Then vertex is same. Base of the triangle is same line and same vertex. The height of the triangles are equal. So in this case, height of all the triangles is equal. Base of all the triangle is same line and same vertex. Since height of all the triangles are equal. So then this is a statement of basic proportionality theorem. If a line drawn parallel to one side of a triangle to intersect other two sides in distinct point, the other two sides are divided in the same ratio. Required to prove AD by BD is equal to AE by EC. DE parallel to BC. Then required to prove AD upon DB and AE upon EC. So go to proof. Join B and CD and then draw DM perpendicular to AC, EN perpendicular to AB. Join BE and DC. Draw perpendicular to AD and perpendicular to AE. So here 90 degree, 90 degree, since DM and EN is the height of the triangle ADE. So this construction is over after. Then area of triangle AD is denoted as area ADE. Then area of AD half into base into height. First take left side. Here left side triangle left side is AB, right side is AC. First take left side area of ADE half into base into height, half into AD into EN. EN is the height, so area of ADE is equal to half into base AD into height EN. Next, area of BDE. Area of BDE is equal to, this is area of BDE is equal to half into base BD. Then see, BDE, triangle BDE and triangle ADE, base is same line and vertex is same. Area of ADE and BDE, area of BDE. Say base of both triangles are same line, vertex is same E, since height of both triangles are equal. ADE and BDE, same vertex, base of both triangles are same line, then height of both triangles are equal, say EN only. So area of BD is equal to half into BD into height EN. Half into BD into EN. Question 2. Divide 1 by 2. Area of ADE by area of BDE is equal to EN cancel, half cancel, then AD by DB, equation 3. Then first here area of ADE take left side, then take right side. Right side. Area of ADA, right side. Half into base AE, height DM. So area of ADE is equal to half into AE into DM. Half into base AE into DM. Half into AE into DM. Again DEC. Before see, first left side two triangles ADE and BDE. After right side two triangle ADE and DEC. First left side two triangle ADE and BDE. After right side two triangle ADE and DEC. So right side area of AD is equal to half into AE into DM. Again area of DEC, same vertex D. Base of both triangles are same line. So height of DEC also is equal to half into EC into DM. Half into EC into DM. Half into EC into DM. For equation 4, equation 5. Same. Divided by 4 by 5. Half cancel. DM cancel. E by EC. EC. Then area of BDE and area of DEC. Triangles of same base, the same parallel lines BC, DE. Area of BDE, area of DEC. Area of BDE, area of DEC. See, DE parallel to BC. DE parallel to BC. Then before, here principle, triangles of same base to same parallels are equal area. Triangles of same base with the same parallels are equal area. Triangle BDE and DEC, same base DE, same parallel BC and DE, DE parallel to BC, same base with the same parallel lines. Then area of BDE is equal to area of DEC. Area of BDE is equal to area of DEC. Then area of ADE by area of BDE is equal to, here denominator BDE, numerator is same. Then denominator area of BDE is equal to area of DEC. Area of BDE is equal to area of DEC. Numerator same. Denominator area of BDE is equal to area of DEC. Compare equation 3 and 6. Compare equation 3. Left hand side area of ADE by BDE. Here also area ADE by BDE. Equation 6, left hand side also area ADE by DEC. Equation 3, area ADE by BDE. Equation 6, area ADE by DEC. So, in equation 3 and 6, left hand sides are equal, then right hand side also equal. AD by DE is equal to AE by EC. Compare equation 3 and equation 6. ADE by area BDE is equal to ADE by DEC. Left hand side also equal, then right hand side also equal. AD by DB is equal to AE by EC. AD by left hand side. Compare equation 3 and 6. This is left hand side. So right hand area of ADE by BDE. Left hand side, right hand side AD by DB. Area ADE by DEC, right hand AE by EC, hence proved. So the conclusion of basic proportionality theorem is a line drawn parallel to one side, D is parallel to BC, then AD upon DB is equal to AE upon EC. If DE parallel to BC, then AD upon BD is equal to AE upon EC. If a line drawn parallel to one side of a triangle, the line intersect other two sides in distinct point, the other two sides divided in the same ratio. If DE parallel to BC, then AD upon BD is equal to AE upon EC. Here over. Thank you for watching.